So welcome everyone to the last lecture, unfortunately, of the mini school on monitoring biodiversity using data cubes. And I don't need to introduce Sandra MacFadyen and Maarten Trekels to you because you met them already 3 times. Yeah? And the plan of today, as far as I know, is open science, sharing and disseminating results from data cubes. Yeah? So Sandra and Maarten, over to you. And I guess people know the rules of the game, use the chat, Q&A, and then at the end, if need be, we can give you the right to ask question in person. Yeah. So please, Sandra, over to you. I think you are the one starting. Yeah.
Yes, thanks so much, Francesca, and thanks everyone for joining us again for this last session, as Francesca has mentioned. I'm just going to take you quickly through what we've done the last 3 sessions. We started off with an introduction session on the 4th, where we looked at biodiversity and data cubes in general. We started off in the next session with a practical session, actually looking at how to build data cubes with GBIF data. And then the last session, I took you through some ecological modeling with data cubes. And I showed you how to create your own data cubes from different sources and to visualize your results on interactive maps and to look at some patterns related to environmental variables. So we ran out of time for that session, but as I did say, the notebooks that are on the GitHub site, those are pretty comprehensive, so I hope you took some time to run through it on your own, and if we have time at the end, you're welcome to ask any questions with that session or any of the other sessions as well. The recordings for those 3 sessions are already up on the NITheCS YouTube site, so I've just put the links in there. But if you go to the NITheCS YouTube site and you click on videos, you'll get the list of all of the videos that we've done, as well as many others. So today we will. Why is it not moving? Oh, there we go. All right, so today we're looking at open science. It's going to be another one of those sessions where Maarten and I will tag team it. So he'll start off looking at how you share and disseminate results in different platforms. I will then take over with a hands-on looking at how you extract data from places like GitHub and Zenodo. And within the notebook itself is some detailed instructions on how you upload your data to Zenodo as well, ensuring that it's free and open source. We'll end off with a questionnaire. So I put a little questionnaire together that if you could please fill in so that we could improve this mini school, but also ask you for some inputs for what is the next mini school you would like to see. So Maarten and I do this biodiversity monitoring with data cubes every year, but we'd like to introduce another mini school, and we'd like to hear from you what you would prefer. All right, once again, as we tag team it, while I'm presenting, Maarten's going to be manning the chat. So if you have any questions throughout the presentation, pop it into the chat. While he's doing it, I'll be in the chat. So there will always be someone manning the chat box. So please feel free to ask questions throughout the presentation. And I think that's going to hand over now to Maarten. So I'm going to stop sharing my screen, and Maarten will take over. Thanks, Maarten.
Thank you very much, Sandra, and good afternoon, everyone. I will start sharing my screen. Okay, let's go back to the presentation a little bit. So just to recap a little bit, we can't say it enough. Our previous lectures are already available online. And if there are any other questions, please don't hesitate to contact us. Our email addresses are at the end of the presentation, so if you have any other questions after this lecture, don't hesitate to contact us. I will start with a little bit about the open science and fair data. I think I covered this already a little bit during our first lecture. Fair data, where FAIR stands for findable, accessible, interoperable, and reusable, is one of the keystone concepts that we have to keep in mind when we are sharing our data. Basically, the tools that we are going to show you today, and mainly focusing on GitHub and Zenodo, are ways to achieve this fair data sharing of your results or for your data. But there are other ways to achieve this, and using GBIF or publishing your data to GBIF is already a way to make your data fair. When you are collecting in the field and you're gonna monitor biodiversity using iNaturalist, this is also a way of fair sharing of your data, and there are many others. So what I'm gonna cover today is not supposed to be a complete overview of what you can do, but at least it gives you an idea how easy it is to achieve this goal, and I will focus mainly then on GitHub and Zenodo. And if you remember from last time, one of the key things for fair sharing is that you have to have a persistent identifier for your data. And Zenodo is a way to achieve this very easily, because when you publish your dataset to Zenodo, you have a citable source that generates automatically a DOI for you. So you will get a persistent identifier for your dataset or anything you want to share online immediately. And this is a DOI is persistent, so it means that at least the metadata that is attached to this dataset will stay online. And I think at the moment, yes, I will now switch to more a practical overview of Zenodo. So if you go to zenodo.org, you will end up on this website, and you will see already a few of the datasets that are just recently uploaded to Zenodo. If you just click on any random dataset or data that is uploaded here, you can see that either this can be a PDF, like here. This is probably a presentation that was uploaded. You can get a preview of what's in that in that repository, and that's most important. You can see here on the right-hand side the DOI that is attached to this dataset. This is the persistent identifier. If you share this with people, they will always end up to this website and always end up as a landing page to your presentation. It also has the license attached, so you can put a license to this. In this case, the CC BY license, which is very important as the reusable component of your data. So it gives you tools to give a license to whatever you want to share. Another thing is you get a sort of standard citation of your data that you can export in any kinds of styles, plus the data itself. In this case, there are no keywords attached to it. Actually, that's a good bad example. In any case, whatever you should do is to put any add keywords to your data to increase the findability of your data. Another nice thing about Zenodo is that you have versioning. So you can see here this version, this document has a version 1 which was uploaded in, and I will probably, it's better that I increase the size of my screen a little bit. That's too much. Yes. version 1, which was uploaded on October the 3rd of 2024, but at least you can upload updated versions without having to create a new DOI to your data. So your DOI stays the same, but it will always point to the latest version of any dataset that you have published here on Zenodo. Another nice thing is that you can have some overview on how many times your page was viewed and how many downloads of your data already happened since it was uploaded to Zenodo. Okay, good. Let's go back to the home page. And you can see here that currently I'm logged in as myself into Zenodo, but Zenodo has a few very convenient integrations. And just for the record, I will log out for a moment. And one of these things is, and this is also something which is very important and something you have to really keep in mind, is that people names are very ambiguous. So if you see a name from someone, it's really hard to say. There could be several people running around with the same name. So as a researcher, I think it's very important to make sure that you uniquely identify yourself. And as you have noticed maybe already during your studies or career, is that often you see this green circle popping up next to people's names. That's the ORCID or the ORCID. If you click on this, and it's again a type of persistent identifier, this person is actually identified by a unique URL containing a unique number. So one of the first advices I give to people when they start publishing or start their scientific career is make sure that you have an ORCID connected to your name that you can track, and you can see in this case it says where you are employed currently, but also it links to all of your publications. Not only your publications that are in peer-reviewed journals. No, if you connect your ORCID with Zenodo, any type of data set that you publish on Zenodo is uniquely connected to your name. So basically, you do get credit for publishing that data on a website of like Zenodo, because it's unambiguously linked to your person. And once you have this ORCID, you can connect it actually to several systems. And if we go back to Zenodo and you press on the login button, you can actually choose. You can still do it the classic way by providing an email address and a password, but you can also sign in with your ORCID or sign in with GitHub for that matters. And if you do that, it will request, of course, my password. You will automatically end up to Zenodo, and your ORCID will be linked to your Zenodo account. And so you can see that here, if you go into the properties, there is a property linked accounts, where you can see that in my case, both my ORCID and my GitHub account are linked to this Zenodo account. And this has a few benefits, and I will try to show you a little bit what these benefits could be for you. Okay, how do I now start sharing data on Zenodo? And in our previous lectures, I showed you how we create from GBIF data, some data cubes containing taxonomy, time, and space as dimensions, and how you can map this or link this to a geopackage, so that you have the geometry attached to your data cubes. I can quickly go back to that lecture here. You can see that at some point I created the data cube and I merged the data together with the grid cells here. One of the things you can do is you can export this data can make it a bit bigger. Please notify me if it's too small to see. Actually, you can, the merge we did with the data frame and the grid system, you can save in a specific format which is called GeoParquet. And this GeoParquet files, it's also an open data format in a certain standard way of providing data in columnar format. You can export the data cube as a Parquet file, which in the notebook you can see. If you go back to my notebook of the second lecture, there is a section where you say how to export your data to a GeoParquet file. I did this already before, so I generated this data cube before, and now I want to actually start sharing this data on Zenodo. How do you do that? We can first look at the manual way of doing this. So there is here a button says add new upload. So we can start making uploads. We can also connect your data to a community. This has several advantages. One of the advantages of adding your data set to a community is findability. If it's part of a certain community online and people are looking around in that community, they will be more easy for them to find your data if they don't know exactly what they're looking for. But in this case, we were not going to bother with that. Also, when I start publishing my data onto Zenodo, I can always go back and change any metadata or other information attached to that file later on. So I can already just start uploading now. So let me take the file that I generated. I click upload files and I take the one that I created last time. In this case, so it starts uploading this data. In principle, you have to provide at least some minimal metadata. And one of the most obvious things is a DOI. I don't have a DOI yet for this dataset. It might be that you registered already a DOI before. In this case, it's not. So I request one from Zenodo. I can already get a DOI now. If I press this button, it will generate my DOI already. That's in case you want to embed your DOI inside your data. But that's not mandatory, so I won't go there now. And then there are a few things, the things with the red star that we have to at least fill out. So what is the type of data that I'm publishing here? In this case, you see what kind of things you can choose here, but what I want to do is I want to register a data set. I give it a title. In this case, it's a biodiversity data cube of South Africa. At level 2 extended quarter-degree grid cells. Oh. I can add multiple titles if I want. The publication date, you can only choose today or a date in the future, or if you published it already beforehand somewhere else, you could use an earlier date, but I keep it on today. I add a creator, which is basically myself. Either you look for people or you can fill them out. In this case, I will just look for myself. Okay, and I save it. I can add a description. In this case, it's not mandatory. It's always good to have a description of your data, that at least people know what to do with it and how to use it. I can add a license to it. In this case, the standard license is the attribution license, the CC BY license. but you can actually start using other types of licenses that are supported by Zenodo. Zenodo is about openly sharing data, so what you will get typically is the most open licenses. If you have closed licenses, it's very difficult to share it on a platform such as Zenodo. I will keep it to the CC BY license. I can add contributors, but then actually quite important section is the keywords. And this is similar to keywords that you put on a publication. So you can actually start saying as a keyword, I wanted to have gbif as keyword because it's gbif data. And it's a data cube. I also want to, why doesn't it add it? I can, for example, also add the fact that it's on South Africa. If people want to find data about South Africa, that they know where to look for. This is generated within a Horizon Europe project called B-cubed. So I add B-cubed as a keyword to it, and so on. It's just to make sure that people are able to find the data that you want to that you are sharing here. Then there is just another date here that I just don't need to add here. Don't worry, I don't have to select the language because it's not any kind of publication in a sense of a document. And then you can add other information. For example, who funded this research? What are some other identifiers that you can use for this data set, and so on and so on. Basically, you can start filling out as much data metadata as possible to ensure that your data set is findable for other people. You can add some related works if there are, add some references, and so on. It goes far, and you can put a lot of metadata there. In any case, the more metadata you put on your record, the better. So I know that this takes a little bit of time, although we are only 20 minutes in our lecture and I'm almost finished. So it might seem a lot of work to get your data in an openly and shareable way published, but this little bit of additional work that you put into publishing your data really helps improving your impact to other projects and other people. So basically, I really recommend you to take your time and fill out all these different types of metadata fields that you can add to this record. For demonstration purposes now, I will keep it to this. I have the basic information there. And so what I can do now is just press the publish button or save it as a draft. But I will publish this. It will ask you, are you really sure that you want to publish? Because you have to be keep in mind that once I publish this, you might remove the data from what you have published, but the metadata stays there and makes sure that there is some trace of whatever you did in the past. So I will publish this data set now. And it's done. So basically, in this case, it's not more than this. There is a version 1 of my dataset that I published today. There is a DOI attached to it, so anyone can now find this. You can see the keywords here. What are the previous example I gave is missing, the license, and how to cite this data. And it's not more than this. This is easy. The additional benefit of this is that this is now directly linked to my ORC ID. So whenever it takes some time, of course. The algorithms need some time to pick this one up, but whenever OrcID now picks up that I published this data set on Zenodo, it will show up in my public profile of ORCID, where this data set is listed as one of the data sets I created. And so in that case, you can get credit when people are starting to reuse that data. You can trace back to the data provider. Okay, I don't know whether there are already pressing questions at this moment. If so, then you can interrupt me. If not, in principle, the dataset should be online immediately. So if I copy this link and put it in the chat, anyone should be able to download this dataset right now, from now, immediately. So there is no lag in getting hold of this data. Okay, good. And by doing this, we basically already fulfilled most of the FAIR principles by publishing our data like this. You don't only can publish data on Zenodo, like I showed before. You can put documents in there. You can use it as a sort of preprint server. So if you have a publication that is not yet officially published, but is in a preprint format, you can use Zenodo as a repository for your preprint. Again, it gets the DOI, so people can start referencing to it. Some publishers already require you to upload it as a preprint to Zenodo. Actually, everything I now explained is for a dataset. What you can also do is put software on Zenodo. And in that case, like you've seen in my profile, my GitHub account is linked to my Zenodo account. So if I create a software and I version this software, I can actually publish my software to Zenodo and get a record of it that people can start referencing. And this is something I want to stress, because software, and specifically scientific software, is often very underrated, and people kind of assume that software pops up out of the blue. But if you really want to make sure that you get credit for the software that you created, you need to create some kind of citable resource of your software. And also this you can do. You can integrate any software that you publish on GitHub back to Zenodo. It will bring us a little bit far to go over all of the steps, but what we can reference to is these tutorials that are created by the Research Institute for Nature and Forest in Belgium. And so there are a lot of very useful tutorials on this website. They should be all in English, but one of the nice things or nice tutorials that they put online on this website is the Zenodo GitHub integration. And so basically this page will explain you how you best integrate GitHub and Zenodo in very simple steps, even with screenshots. And so you can make sure that if you add any release on GitHub, your result will show up in Zenodo, which is a very useful thing to do. And how does this show up? I did this in the past for some of my data. So if I go to my data, so let me just quickly check if there is another one I can show. Sometimes it doesn't really. I'm still searching within the community. You have to be a bit careful when you do this. So here is a data set that I published, actually the publishing of a GitHub repository with some versioning on top of it. And you see that here there is the integration with GitHub. So this is basically just a copy of your GitHub repository on Zenodo, which is downloadable here, but you can also go back to the original data, which is still on GitHub. And most importantly, you have a citable resource. So instead of citing your GitHub repository, you cite a DOI that has the metadata attached to it. And so you can see people can start looking for this in keywords and so on. And you get some kind of idea how many people are using your dataset. You see that this dataset is already 32 times downloaded, and people are reusing this. In principle, if people adhere to the FAIR principles, they should also cite the use of this dataset later on. If you want to go through this GitHub integration Zenodo, please go and have a look at this tutorial. And you will learn more about it. If you want to learn more about Git and GitHub, there are other lectures within the NITheCS schools that are dealing with Git and GitHub. Please, I advise you to go and have a look at the NITheCS website, where you can actually start reusing all the concepts of Git and GitHub there. Another nice resource from the B-Cubed project that I'm working on is on the B-Cubed website. Well, basically, this is if you go to b-cubed.eu, you end up to the general website about how to make data cubes out of GBIF data. But there is a guides and tutorial sections on this website. If you click on this one, you will end up on this website, which is a searchable website. So if you have any questions on how to deal with the data cubes, you can search this documentation website. What can you find on this website? Specifications of the data cube. How are the data cubes developed? What are the requirements for this? So if you want to read more on how to make these data cubes, this is the place to go. But there is some software already available on B-Cubed that you can start looking at, and some other tutorials that are used within this project. So basically, if you want to know more about how to create these data cubes in a fair way, how to share them, how to use them, you can use the B-Cubed documentation website. This documentation website is actually also built on GitHub. So it's fair. You can see all the versioning of the documentations on GitHub, what changed, and so on. So any kind of information that I was going to in one of the first lectures, I think maybe the second lecture, how to download the cube from GBIF, you can actually find here, and you can go over all the steps that I showed you in previous lectures also on this website. If by chance you see that there is an issue with this documentation website or any of the software that was developed within a project and that is shared on GitHub, there is this one last feature of GitHub that I really want to show, and what really makes it a very strong and useful tool is if you go to one of these data softwares. Again, this software is on GitHub, but it's also already published on Zenodo. So you see that that there is the Zenodo link is already there. If we click this one, you come to the Zenodo website of this software, but you can also go back to the GitHub repository. In any case, if you start using the software, if you start seeing any issues that are popping up with the software, there is this issue mechanism within GitHub. So if for any reason you see an issue with the documentation website, or you see something which is not working, or you want more information on the software, don't hesitate to go to the issue section and create a new issue. And there you can just explain what your problems are, and then the people maintaining the software will, or even the documentation, will be able to guide you and help you and figure out where the issue is coming from. So very, very useful. And please don't hesitate to start using this. Then one last thing, we shared before on the NITheCS website the different Colab notebooks that we were using. Also Google and Google Colab have a very nice mechanism to share your notebooks that you are creating with your scientific problems onto GitHub. And so this is the one that I was using for my demo. If I now want to share this notebook on GitHub or integrate it with GitHub, there is actually a way in Google Colab to save a copy in GitHub. So if I click this button, I can actually choose in what kind of repository I want to save this. So in this case, for example, if we want to share it on the NITheCS Mini-school GitHub repository, I can give it a name, I can say what I changed or what I did in this notebook, and I click OK. Once I do this, it will publish it on the NITheCS GitHub repository with a comment, and in the comment will be this commit message. And so you get again a versioning of any kind of script that you developed in Google Colab. So even Google Colab has provided you a way to version anything that you create into onto GitHub. And then again, once it's on GitHub, you can integrate it again with Zenodo. And with that, I think I covered most of what I wanted to say today, and I will give the floor back to Sandra. Thank you for listening.
Thanks, Maarten. All right, I'm going to share my screen. Make sure I get the right one. Okay. All right. Just going to move some things around there quickly. All right, so Maarten's taken you through the different processes through Zenodo on how to upload your data. I'm going to take you through a practical now using CodeLab and on how to access data from different sources. So it will be a bit of a recap from what we've done previously in different sections. And then it will also show you how to upload data to something like Zenodo. Something we haven't dealt with is iNaturalist. So there's a bonus section at the end that if we have time, we can cover. But as I've mentioned, if we don't end up getting through all the notebooks, don't worry about that. It is hopefully quite detailed explanations in each of those notebooks, so you should be able to cope without it. And you're also welcome to always contact us. All right, so as Maarten mentioned, I think I put in the chat already, we've got a GitHub site for our NITheCS group, and we're putting all of our mini schools in there. We're going to be changing it a little bit, so some of the links might not work in the future, but if you keep going onto our mini school GitHub site, then you'll be able to access all the information there, and we're going to rename a lot of the files so that they make a lot more sense. And once we add on our new mini school, then we'll probably have different folders. So if you click on that link, this just gives a brief introduction to our program in general. And then because we've only got this mini school at the moment, you go directly into this biodiversity and data cubes mini school. We did Prac 2 already, we've done Prac 3, and so the next one is Colab Prac 4. So if you double click on that, it should open it up in this environment. Let me zoom in a little bit You can see a bit better. All right, and as Maarten just showed you, if you're working in Colab and you save that notebook to a GitHub site, you've got a little tick at the bottom. I don't know if you noticed when he was busy saving, that said add a button that opens in Colab. So that's exactly what this little button is here. That was added because you put that tick that said that you want to be able to open it in Colab again. So if I click on this button, this is what happened last time when we were working through the notebook that was running with Python. And as I said, I've got multiple G drives or rather Google accounts. So as soon as I've opened this file, it opens it in a specific Google account. Now I want to change this, so I will just click on the top here and change it to my other Google account, which is through NITheCS. All right, it will open up another version. And the same way with the Python program. If you don't save a copy of this onto your drive, your G drive itself, you won't be able to change a lot of this stuff. You won't be able to save it. And in this scenario, R doesn't really use much interactive mapping, so you shouldn't get that many errors. But just to be on the safe side, it's always good practice to go to File and you save a copy in your drive. As soon as you do that, it's going to open up with the same notebook, but with copy in front of it. And that's why it's important for you to first change your account. So you make sure that you're saving it now into the correct account. So you can go and rename this anything you want. All right, just so that you know exactly which version you're working on. Now this should run fine. What happened previously in the last session with the Python, we had some troubles authenticating the notebook and it didn't trust it. So I just double checked that after the session last week. And for it to work, if it didn't work from your side, you need to first go to this runtime and run all before it works. In this scenario, you don't have to do that because we don't have any interactive mapping. So it doesn't need to trust this notebook in that way. You can click on the table of contents on there if you want to be able to jump to different sections, because I have made it in a way that you can jump. But the important thing is that we're not working in Python anymore. We're working in R. So let's have a look and see what happens while we work in this. You might get an error, and then I'm going to show you how to jump to a different kernel. So here we've got just some introductory text on the session. We've been looking at GitHub, Zenodo, and GBIF, but there are other options out there for accessing open source data and also for sharing your data. Some of these are not free, so we focused on the free ones in this session. But the information is here for you to go and have a look at whenever you want to expand your knowledge. And as I said, if you scroll down, we're going to be starting in R today. So the first thing we need to do is just to make sure that we've loaded all the packages. Now, this can take a while, so I've changed some of it. So I don't want you to run it exactly just yet. I've commented out a lot of options, so you'll see there's some code here that you can run once you've uncommented it. At the moment, the only thing that's going to run is to check which packages are installed, and then it's going to install this SF. So I did this on my version, and I only had SF missing. But SF is a spatial package, so it's spatial features, and it's quite a heavy package. So you can try it, but if it takes too long, rather just cancel the code and then carry on. And you can do this in your own time as well. So you can go back and uncomment the reduce list that saves time, or you can go and do everything, which is this one over here, which is the full list. And then uncomment this section here that just runs through it and installs what's not there. So the nice thing about Colab is it already comes with a whole lot of libraries loaded. So if you haven't managed to install the SF library, I know that's not going to work. And also the Zen 4 I commented out. So if I run this now, all right, good. I wanted this to do this. Now it's going to give me an error. Hopefully, let's see. Okay, so it's given an error, and the first thing it says is that library is not defined, but you know that library is an R function. So that's when you need to make sure that you're actually in an R kernel. So on the bottom right-hand side here, you'll see my runtime is set to Python 3. So on that button, you press it, and you change the runtime type, and you change it over here from Python 3, change it to R, and you save. Now on the bottom right-hand side, you'll see connecting to R, and it's now initialized. R is sitting there. If we run this again, we shouldn't get an error. If you do get an error that says that there's a missing package, it means that you have to go and install it. So now that we've set it to an R environment, this should be exactly the same as what you do in your own R Studio, in your console on your local computers. So I've gone through a few duplications, so I might skip this. This is just to take you through exactly the process that we did with Python last week. You can do the same thing to access GBIF data, but through R. And once again, I built a function here for you that you can just run that loads data from a URL, which is the zip file that you get directly from GBIF when you request data from them. So this is what we did last week. So I've already got one that I've shared. So if we run this function, it's not going to do anything. It's just loaded it, but there's a tick. And now if I go down here and I run this section, we should get a header with a lot of, from a table that includes these columns, which I've filtered out. The same approach for a CSV file, for example, on GitHub. So this is something that's sitting on our data folder in our GitHub for NITheCS. If we run that, it will do the same thing. All right. And you'll see this is exactly what we did in Python. So this is just to show you that you can do it in R and the versatility of Colab, that you can switch programming languages to be able to run different things. You can filter out information if you want to split it out by year and month, because it originally comes as year and month in one column. We've split it now to year in one column and month in another column. All right, I'm going to skip this. It's just another file that you can have a look at. All right, now this is the section here that you will need to have SF installed. So if you had a problem installing it, this won't work for you. But you can go back later and install everything, and then this should work. Okay, so I grayed out, even though I had installed it, I grayed out the library SF, so that's why it's not seeing it. So if I uncomment that and run it again, and then go down back to that section, here we go, then I run it again, oh, or not, maybe it's still thinking. Ah, all right, so it's reset itself. So what happens normally is if you install a package to your local setting, it will stay there until you've restarted your kernel. So in this case, it's actually still wants my SF package. So if I could run this, which is going to then start installing SF. The reason it's doing that is it's looking for which packages are missing. This one doesn't have SF in it, so it circles through that. So it didn't give me anything when it printed out the missing packages, but I know SF is missing, so I'm installing it on its own. So you'll see this takes a little while. So I'm going to let that run while I go down to the next section. So just keep scrolling down. Right, so this is where we got the error because SF wasn't installed successfully, so I couldn't use this function. But this essentially makes a map with, well, it essentially turns those points into points that have got decimal latitude and longitudes that you can plot later. So the next section creates the quarter-degree grid. So this is exactly what we did in Python. And it won't work if you haven't got SF installed. So this st make grid is also a SF function. And once again, you can count the different information, and you can plot it in different ways. All right, so this count as grid won't have been created, this one, because it comes from a spatial object that we created once we'd installed the SF package. So unfortunately, the R functionality in Colab does take a bit longer than the Python functionality. So if you're just patient and let it execute, you can run through all this code on your own at a later stage, and it will work. All right, if we ignore the spatial component and we go back to a Zenodo environment, this is exactly what Maarten took you through earlier. If you know of a file that you need to access, so if you go to the Zenodo records, and we want to take, for example, this West Indian coral diversity from 1998 to 2022. Here's the data. If we go down and we have a look at this, and we right-click and we copy that link, that's the link that we need to paste into our Colab environment. So this is the link here. All right, so I'm just going to stop that install because it's taking much longer even than I expected. So you can cancel a run. So it's just going to cancel that block. There we go. So I need my Zenodo to run. So if you're having another block running, it's not going to work. So if you do this, you should get that data. So this is this data directly accessed from Zenodo. You can do the same thing using the Zenodo API. So you go into your API records, but you need, instead of that link, you need the record ID. So over here, if I go back to this example, this is the data that we're trying to access. All right. If we want the project ID, where is it? Okay, it's also sitting on Dryad. All right, in this example here, it's not opening. Anyway, if we go into here and we put in that record ID, we'll get more information about it. So you need to know all this information to be able to be able to read in these data. All right. So you need to filter that out with the API. You won't be able to find it in that way. So that's important to know once you're setting things up. Now you can do, once you've got that set up, it's the same thing about downloading a file, and then you can read all the information. The next section is to upload it yourself. So if you want to upload data, you can also do it through R directly using the Zen for R package. So we didn't install that in earlier because it took too much time. But as I said, this will work for you. So using this Zen for R package, you can do the same thing that Maarten showed you through the web interface. You can also do it directly through R and through a notebook. So I've commented out this whole section because I knew it would take too long to run that Zen for R. But on your own time, you can go and run through it. And as I said, I've got a bonus section at the bottom here that also shows you how you can use different packages to read in iNaturalist data. and also plot it to see how things have changed over time. So I'm not going to run through that now, but if you go through it in your own time, it will work. And importantly, to note, please remember this link to our site. So I'm just going to put it in the chat again. Should actually still be there. We'll always update our notebooks there, and we'll put more information there. So keep having a look at that, and keep using the notebooks that we put there. We try to make them as useful as possible so that you can run through it yourself. All right, so we've got a question in the chat. It says that there's an error while running the iNaturalist. So I always have to tell myself this, but the error message is actually telling you exactly what's wrong. So take the time to read it carefully so that you can figure out what's happening. And in this error that's pasted in here, it says that there is no package called RinNat. So that means that RinNat has not been installed. So that means you need to go back up to the top and make sure that RinNat is installed, or you can go and put in a section here. You can add in, because you've copied this now to your own G drive, you can add in a new section of code here, and you can just type in there, install packages, and put in there, and just put in there RinNat. And then that will actually install the package for you. So keep an eye on what the messages come back as saying when they've got when you get an error. It is actually telling you what's wrong. You just need to read it more carefully when you get a chance. Then I'm quickly going to paste into the chat while I wrap up. All right, I just put into the chat box the form that we'd really like you to fill in to help us improve this mini school, and also give us ideas on what other mini schools you would like to see. Also, Maarten pasted the link to the Be Cubed website. Please keep looking at that as well, because that's being improved daily, and we will be adding on more tutorials, and we'll be adding on notebooks and different packages. So please keep an eye on that as well, and you'll definitely get some nifty ideas and notebooks there to follow. So with that, I think we've basically ended this biodiversity monitoring with NITheCS Mini-school, and we have a few minutes for some questions if you do. So please go ahead and either raise your hand or put something in the chat, and we'll try to respond. And please take the time to fill out that form if you get a chance. We'd really like your feedback, and we'd like to present another mini school, and we just want to hear from you what you'd like to see. There's no point us presenting something that we might be interested in, but you're not. So please give us some advice on that.
I think people need a little bit of encouragement.
Yeah, if you're shy, email addresses are also on the site and on the different slides that we've shared with you. So please, you're welcome to email us. We can help you off of the course. If you've got some specific questions for your own research, please go ahead.
How many people have filled out the form, Sandra? Can you check it?
Check quickly.
I think I don't have access to the back end. Please, participants, fill out the form.
Yes, please. We'd really appreciate that. Even if you do it at the end as well, please do that. I think we don't need to fill the Google again if we've done it before. All right, Mukta was on last year's Google form. You'll notice when you open it, it's changed a little bit. So we have a new section just above what topics you would like to see We've also asked about the pace at which this course is delivered, if it's appropriate, if you'd like us to slow down or speed up, and then also giving some open ideas for how we could improve it in future, and what are the things that you most valued from it, so that we could apply that to the next mini school as well. And then what's the same as last year is the list of topics that you might want to see. These are topics that Maarten and I have present in other places, like Organization for Tropical Studies or through the museum. So they're already set up, but if you want something completely different, there's another section that you can just go type it out and put in anything that you want. So yeah, it's gone 3 o'clock. So I guess the only thing that is left is to thank everyone.
To ask a question in person, just raise your hand and I can give you the the permission to talk. Yeah, if that makes it easier to get some feedback.
And again, if you're shy or don't dare to talk here, you have our email addresses or use the Google form.
Yeah. Okay, nobody seems to raise the hand. Okay, there are a few thank yous in the chat. Yeah, if nobody has questions, then I will thank you on behalf of everyone. Yeah, so thank you very much, Sandra. Thank you, Maarten. I think it was really very interesting. In particular, I really enjoyed the open science part. That's very important, and it's very close to the heart of NITheCS. So thank you very much for stressing that at the beginning of the lecture. Yeah, and I hope that maybe next year you will offer something else. Yeah, so that we keep building the community of biodiversity monitoring in South Africa and the rest of the world. Yeah. So thank you very much, Sandra. Thank you very much, Maarten. We appreciate very much your enthusiasm and your offering of the schools. Yeah, and yeah, and hopefully we will see Sandra in person in July and Maarten maybe later in the year. Yeah. Thank you very much.
Thank you very much.
For the best, and thank you very much to all the participants for being with us the whole month. Yeah. And please join us for the next mini school as well. Yeah.